Hello there, my name is Charles Wasfani Msipa, your e-tutor on our online tutorial platform on my UNISA. I wish to welcome you to this module XAT 1512. I'll be assisting you to understand some of the challenging concepts in this course. This is just an opening video to welcome you. Following this welcome note, there is a video clip. That video is going to give you an overview of our course throughout the year, and it's sort of give an idea of what calculus is all about and where we're going to start. So after this, from now on, what we're going to do, I'm going to post you activities weekly in kind of tutorials to help you understand the concepts. Please don't hesitate to ask me questions anytime. There is my cell phone number, which you can get me on WhatsApp, and my email also. If you need to send something or ask something via email, you can do that. But mostly the questions you have got about this course, especially in terms of content, you can post your questions on our discussion forum on our UNISA platform. So for now, I'll leave you to enjoy the introductory video explaining what is calculus. So see you in the next presentation.
Calculus is one of the very important branches of mathematics, which I think at the beginning like this, when you have not experienced it, it's very difficult to explain what calculus is. But I would like to advance you here by telling you that calculus, in this course, we're going to deal with what we call differential calculus and the integral calculus. But all this starts from a simple idea which we can link to the gradient of a straight line, knowing that the equation of a straight line is y is equal to mx plus c, where m is the slope of the line, which is calculated this way using any 2 points on the line. Say you've got here a point there and a point there, and suppose that the coordinates here are x2, y2, and the coordinates there are x1, y1. So using these coordinates, you can calculate this slope this way. Now, both integral differential calculus and integral calculus hinge on a very important concept of what we call the limit. So that is actually going to be our first chapter, building actually the foundation for these two crucial chapters in our course. So that limit, the concept of limit, again, we can take it from here by noting that the gradient of a line like this is a constant. In other words, it doesn't change at any point of the line. But if we were to consider a curve of a function of this nature, let's say y equals to f of x, I think it is clear to anyone that the slope of the curve here is different from the slope of the curve there, and actually the slope of this curve is different from one point to the other, which are on the points on the curve. So then let's say you were to have a line like this, which is a tangent line there, which shares a common point, a unique common point with the curve. Then we will say the slope of the curve at that point is actually the slope of the tangent line, because if the point here is shared by the curve and then this point you have to slide along this line, then it will experience the slope of the tangent line. So we say the slope of the curve here is the slope of the tangent line. But now, when you look at the curve, this is a slope only at one point, which we now can say at that instant when x is equals to x0, there is a slope which the curve shares with the line. Now, to approximate that slope, I think we need to do something like this. Let's say we draw a second line there between this point and another point on the line there. I think you can see now that this second line also is got a constant slope and the tangent is got a constant slope, but the curve still has got a varying slope between these 2 points. But the slope of the second, we can take it as an average slope of the curve between these 2 points. But now, to approximate the slope at this point, at this instant when x is equals to 0, we might need to do something which looks as follows. In other words, we generate a sequence of second lines here by sliding this point along the curve, and you'll notice that as you go nearer and nearer to this curve, the gradient of the second line will be changing and becoming closer and closer to that of the tangent line. This is what we experience in this kind of a diagram. Let's focus on the blue lines here as the seconds. In this case, I'm looking at the seconds which have got the other point on the right hand side of this point where we're looking at the gradient at that point, particular point. So the first second here, S1 on the positive here, will be having that slope which is a lot bigger than that of the tangent line, the green line here. So if we come to second number 2, we will see that this gradient will be lower than that one, and to 3 it will still be lower, and at 4 it will be lower. If we continue sliding this point closer and closer, you will see that this gradient is going to approximate the gradient of tangent line. And then even if we do that from the left hand side, you will see that this second has got actually negative gradient because the slope is going downwards. As you come closer and closer, you can see that at this point here, the line actually looks horizontal. In this case, the gradient will be 0, and after that the gradient here starts to be positive because the line is increasing as you go to the left. And as you come closer and closer to this point, you will see that this second, second number 4, which is now on the left, is also, its gradient is also approaching the gradient of the tangent line. In this case, we number this x second 1 from the side of left, second 2, and the second 3, second 4. Actually, this will be second number 5. As you can see, the gradient is coming closer and closer. So this idea actually it takes us to the idea of the limit, because as this second is coming closer and closer, very close, we will take a point which is very close to S. The second almost like touching the tangent line, and now it's approximating that. So this idea whereby if you check what we're doing here, we started with this distance for the first second, and that distance from X to this point here, we can take as what we call change in X, which in this case now if we pick a point here, X would have X minus X 0, and we call that delta X, which actually signifies change in X. So as you can see now, as the change in X is being reduced by this process, you can see here is less and less and less. Actually, this change in X becoming smaller and smaller in such a that as we're coming close to this point X, we notice that this change in X actually approaches 0. now it's becoming smaller and smaller towards 0. And similarly, this side happens from here. The change in x will be this, but when we get to this point, we can see that the change in x is becoming smaller and smaller. Also, we can say this change is becoming smaller and smaller, approaching 0. So now, as well, looking at this change in x approaching 0, we can see that the gradient also, the gradient of the second line also approaches the gradient of the tangent line. And this happens on both sides when you look at the seconds on the right and when you look at the seconds on the left. So this kind of an idea is what takes us to the concept of a limit, which is going to be very crucial in this course. So here I'm just trying to illustratively give an idea of how to start talking about the concept of a limit, because when we talk differentiation or talk of derivatives, actually what we are going to call derivatives will be some kind of a limit which we shall experience. And then the other idea which actually touches the next crucial chapter is when we consider a curve like this of a function. Let's say this curve here could be a river which is meandering, and we can take our horizontal axis here maybe as a straight fence or as a straight road. So if we're interested, let's say between 2 points from there and there, we're interested in finding what is the area between the river and this straight fence here. We all notice that there is no formula which can use for this kind of an area. But let's see how we can try to think along the lines again which take us to the idea of a limit. We first of all consider this kind of situation. We can have a blue line there horizontally, which is tangent there, and a brown line there which is tangent there. What is clear to us is that the area between the horizontal axis and the curve lies between the area which is here and the area which is bounded by this blue line. So the area is actually, or the area under this curve between these 2 points, let's say A and a B, is actually sandwiched between the area which is limited by the brown line there. Sorry, I think I made a mistake in shading here. So the area which is limited by the blue line there, we can see that it gives us this extra area which is actually not there, which is not allocated. But also the area limited by the blue line also makes us lose this area there. So then we can again consider another process which is actually takes us to the idea of a limit, which gives us an idea of how we can determine the area of this between the horizontal and the red curve. So this is what we can do. Let's say, for example, we can divide this interval from A to B into 1, 2, 3, 4 equal parts, and you can see that when we now break this blue line which was at this level, now the area which is covered by the blue limits there increases slightly. Even here, I think you can see that this line can go there, and then this one can go there. So what we notice here that by doing this kind of a division, the area which is limited by the blue line and under the red line, the curve is actually increased as compared to what we had there. There we lost all that, but with this kind of divisions, we've increased Now we've accumulated more area under the blue segments here, and this part, which was before covered by the brown line, is no longer there. Now, in what we covered now in excess via the red segment, the brown segment is actually less. So continuing this kind of an idea, we can see that the divisions here between the lines, they are becoming smaller and smaller, which we can also take between the 2 points there. We can take that as change in x, so change x from there to there. In this case, if we take the divisions equal, there's a unique change in x because of that finger. But again, what we see that the area under the blue segments is increasing, and the area in excess above the curve is also decreasing. So this one, the area in the blue line, the curve is increasing, but the area in excess is decreasing. Again, we see that the area under the red curve is actually squeezed between this area which is increasing here and that area, outer area, which is decreasing. So in other words, what we're actually saying is that if we get more divisions, like you can see here now, change x is even smaller, and you can say here is 10 to 0. What happens actually is that the area which is in excess here, though it's more, but is decreasing towards the area under the curve. And again, the area which is limited by this below the blue segments is also increasing. And now was saying, the upper area, which is actually limited by the brown segments, is greater than the area under the curve of f of x. Let's say curve of f of x, but that one is also greater than the lower area, which is limited by the blue segments. But because this one is increasing and that one is increasing, now that shows us that as we decrease the distance between these segments, this area actually approaches the area limited by the curve, and this one approaches the area limited by the curve. Now these two areas squeeze the area under the red curve, and this again takes us to the idea of a limit. As you shall see, this will take us to a very interesting and exciting piece of mathematics which we are going to enjoy and apply in many applications of mathematics, especially in calculus. So I hope this sort of takes you, excites you to try to discover this world of mathematics with concepts like limits, and later learn how they take us to the idea of differential calculus, which also is going to evolve when we do the kind of a reverse process of this, which is going to take us to what you call integral calculus, and from that we're also going to get many other interesting topics which are add-on or further developments of these two topics. So for now, I would like to say thank you for listening, and I hope that you're going to find this very exciting doing your differential calculus and integral calculus for the first time.